Hi friends, let's continue our journey on Spring Data JPA. If you watched previous video, you probably have clear understanding on what is Spring Data, how and why you should use it. If you have not watched it yet, I highly recommend you to watch this. You can check the video link here on the top and also in the description. Now in this video, we are going to explore the concept of entity. We'll also learn what is ORM. We'll set up new Spring Boot project, show you how to configure your application to connect with the database and various features of the entities. It is going to be a very exciting session. So let's get started. I will start by creating a new Spring Boot project from scratch. For this, I am going to use my favorite online tool. In your browser, go to start.spring.io. From here, select Java as language and Maven as project. Now for Spring Boot, at the time of this recording, the latest Spring Boot version is 3.5.4. I am going to use that. Now it's time to add some metadata. For the group name, it's my domain name in reverse order. That is com.learn with Iftekhar. Then provide the artifact name. Let's say it is JPA-demo. I am going to keep all the other fields as they are. Now for the packaging, select jar, and for Java version, my installed Java version is 21, so I am going to use that. Now it's time to add the dependencies for the project. The first dependency that I need is Spring Data JPA. So search for JPA. Here, this is the dependency that we need. Select this one. Then we need another dependency. We are going to use PostgreSQL as a database, so we need to add PostgreSQL Driver. So that's all for the dependencies that we need right now. Now here, click this generate button to generate the project. Our project is generated and downloaded as a zip file. Go ahead, unzip it and open it in your favorite IDE. Here, I have opened this project in IntelliJ IDEA. On the left sidebar, you can see the files and folder of the project. And here we have this pom.xml file. The necessary dependencies and the metadata are defined in the pom.xml file. Here at the top, we have this parent tag with a declaration of the Spring Boot parent. Then we have this metadata. Let's scroll down a little bit. Here we have the dependencies that we have added. Now let's start the project and see this in action. To start the project, click the play icon at the top or use the shortcut Ctrl+R. So click the icon to start the project. So here the console is opened. Let's expand the console a little bit. Here we have this message. Process finished with exit code 1. It means our project has failed to start. Let's scroll up. Here we have this message, application failed to start. And here it provides a description about the issue. The reason is failed to configure data source. The URL attribute is not specified. Okay, let's minimize the console. So why was that error? Here we have added Spring Data JPA as a dependency. So whenever we start the project, our Spring Boot tries to connect with the database. As we have not configured any database yet, so it failed to connect with that and it throws that error and stops running. Let's fix this. Let's configure our Spring Boot to connect with the database. Open the application.properties file from src resources folder. Here, in this file, we need to provide the necessary configurations like database URL, username, password, and many other properties to connect with the database. Let's do that. First, we need to provide the database URL. We can provide it using the property spring.datasource.url. And for the PostgreSQL, the database URL is jdbc://PostgreSQL:// then localhost:/ then the port. The PostgreSQL is running on my default port, that is 5432. Now we need to provide the database username. Spring.datasource.url username. Giving my database username. Now the database password, spring.datasource.password, providing my database password. Now we need to provide a driver class name. For the PostgreSQL, this is org.postgresql.driver. Why we need this driver? This driver class name in Spring Data JPA tells the JDBC driver manager which specific driver class to load and instantiate for establishing connection to our database. Though modern JDBC drivers often auto-register themselves, explicitly specifying the class name ensures the correct driver is loaded and provide clarity about which database technology our application is using. Now we need to configure another property, database platform, spring.jpa.database-platform, and this is org.hibernate.ddl-auto. This database platform in Spring Data JPA provides abstraction over different database vendors like MySQL, PostgreSQL, Oracle, and many other supported database through dialects. This allows us to write database agnostic code while automatically handling vendor-specific SQL syntax and features. This enables easy database switching and leverages database-specific optimizations without changing our application code. Now, beside these basic configurations of the database in the application, I want to specify some additional configurations. First, let's configure our application to log the SQL in the console. By default, it is disabled. We need to enable it. We can do this using the configuration spring.jpa.showSQL and set it to true. Please note that in the production, you should not log the queries in the console. You need to disable it. Instead, if you need to check the logs, you should write the logs in a separate log file. Now, let's make the query in our console formatted. To view the query formatted, we need spring.jpa.properties.hibernate.format.sql and set it to true. Now, we'll be able to view the executed query formatted in the console. One final configuration we need is spring.jpa.hibernate.ddl-auto. This DDL-auto controls how Hibernate will handle our database schema. Here, we can choose one of these 8 available options. Update, create only, create drop, then we have this none, truncate, and validate. Now, let me explain some of the important options provided by DDL-auto. First one, this update. This is what we are going to use in this tutorial. Setting DDL-auto to update means that Hibernate will automatically create any new table or columns in the database based on our entity classes if necessary, but it won't delete or modify any existing data. This is super convenient for development where we often make changes to our entities and want those changes to reflect in the database without manually updating the schema. Then we have this create drop. When we have this create drop, this recreates the database tables and columns every time we start the application and it also drops them when the app stops, ensuring a clean database every time. Then we have this create. If we choose this option, it will drop and recreate the database tables and columns every time the application starts, but will not drop when the application is stopped. This can be useful for testing, but it also means any data will be lost on restart. Then we have this none. This is simply disable this DDL operation. And for this validate, this only checks if the schema matches our entities. If it does not, the application won't start. Here, I am choosing the update. So, by using update, we are telling Hibernate to take care of the schema updates without touching any existing data. It's a good balance for development, but not something we'd use in the production. Now, let's start our application and check if it works. Here, I'm using the shortcut Ctrl+R to start the project. This time, our application started successfully. Here, you see the message, process is finished with exit code 0. And That is because it has successfully connected with the database. Now, let's take a step back and look at the big picture of our application model. Here, this is the class diagram that shows the core concept that we are gonna work with. We have this employee, this address, assign task to the employee, and projects. Let's understand them piece by piece. So, first we have this address. We have one-to-one relationship between employee and address. So, this means an employee can have only one address, and the address belongs to only one employee. Now, this is an assumption I am making in this application we are gonna build. Chances are, in different application, an employee may have many addresses. So, don't take what I am showing here and apply it in every project. Your application model should be designed based on the application requirements. Our task is to understand the Spring Data JPA concepts, not the database itself. Next, we have tasks and projects. One employee can have many tasks to do, and the task belongs to one employee. Here, this asterisk represents many. Next, we have project. An employee can have many projects to do in his work, and a project may belong to many employees. Typically, in an office, there are many employees work in a project. So, there we have many-to-many relationships between these two concepts or entities. Now, let's bring this model to life. So, next we are gonna create our first entity. But before that, let's try to understand what is the ORM. ORM stands for Object-Relational Mapping. In the Java project, like this Spring Boot application, Java deals with object with fields and reference. On the other hand, database deals with tables, rows, columns, and foreign keys. Because of that mismatch, we need to write a lot of boilerplate code to query the database, then map the result set with the Java object. So, with the ORM, we can map easily with the table. It automatically translates the Java object into the database table and vice versa. Classes are mapped with tables, fields with the database columns, reference with the foreign keys. This means with ORM, we can now work with our data if it's just another Java object without having to write a lot of manual SQL code. And to map the Java class with the database, we use the annotation entity. Okay, let me show you. Let's create our entity. Entity is a simple plain Java class with special annotation. The first entity I am going to create is for employee. In our root package, creating a new Java class, name it employee. Here, our employee will have couple of properties. Every employee will have an ID, private, it will be long, name it ID. Then our employee will have first name, private, string, first name, then last name. Let's copy this field and paste it below and update the name to last name. Then each employee will have an email address. Next, we'll store when the employee has joined the company. It will be private, then local date, and it is our hire date. Here, we need to import this local date. Let's import it from java time.localDate package. And finally, we'll store the employee's salary. Private, it will type double and name this field salary. Now, we need to create constructors. Hibernate requires us to have no args construct. Let's create it. Right click, generate. Here, you can see the shortcut command plus N. I'll use that shortcut later on. Then, select constructor and click this, select none. Our no args constructor is created. Now, I will create another constructor with the necessary arguments. Again, generate, constructor, select all the fields. Actually, we don't need to select this ID. It will be auto-generated. We'll use our database to auto-generate this ID for us. So, let's unselect this ID and click OK. So, our constructor is generated. Now, we need to generate the getter and setter of the fields. Generate, getter and setter. Select all the fields and click OK. Now, this is our plain Java class. There's nothing special about it. To make this employee class represent the employee table in the database, we need to map these to the database table. Java Persistence API provides a way to do this easily. For that, we can make it an entity by using annotation entity. Make sure you import this from jakarta.persistence.entity. Here, it is showing an error. Let's check what the problem is. The error says the persistence entity employee should have a primary key. What does it mean? Every database table must have a primary key. Since this employee class will map to an employee table in the database, we need to specify which property of this class will act as the primary key. We have already defined the properties of the employee class, but we have not designated any of them as the primary key yet. Here, I will make this ID property the primary key of the employee class. To mark this ID as the primary key, we need to annotate this ID property with the ID annotation. This tells JPA that this property will act as the primary key. Once we add the annotation, the error is resolved. Now, let's start the project. So, process finished with exit code 1, means it failed to start. Let's see what is the problem. Scrolling up here, see, check here, we have this unable to build Hibernate session factory. Let's check why. Unable to open JDBC connection for DDL execution. Okay, here we have a little more details. Connection to localhost 5432 refused. Check that hostname and port are correct. Okay, minimize the console. Let's check our application.properties file. Here we have this URL. Beside this URL, we need to specifically set the name of the database. So we need to create the database. Let's connect with the database and create one. For that, we can use either a command line tool or a GUI interface like pgadmin. But my IntelliJ IDEA Ultimate Edition includes a built-in database tool which I will use here. However, you can use any database client or command line tool you are comfortable with. Here, click on this database icon in the sidebar. Click the plus icon. Select data source and search for PostgreSQL. Here, we can configure the database settings to connect with the database from our IDE. Let's keep the default settings for now. Here, provide the database username. Now, enter the database password. My database is running on the default port, it is 5432, so we do not need to change this. Here, you can see we have this warning mentioning that the driver file is missing. This is because I have fresh IntelliJ IDEA installed, and to connect with the database using my IDE, I need an additional driver that is missing. Let's download the driver. So our driver is downloaded. Let's test if we can connect with it. So our connection is successful. Click OK. Now here you can see the database listed in the database tool. Let's create our new database. Select this localhost, right click, then select new database. Here give the database a name. Let's call it employee_management. Click OK. Here the new database is not showing up. Let's refresh. Still not showing. Okay, click here, and this is our employee management database. Mark this checkbox. Now refresh again, and here we have this database listed. At this point, there are no tables in the database. Let's check the public schema. Here, no tables yet. We will create those shortly. Now, back to our application.properties file. Here, in our database URL, here we need to provide a database name. That was employee_management. Now, let's start the project. Here in the console, here is the query that a new employee table has been created in the database. And here is the necessary fields that we have defined in our employee class. So let's check the database to confirm. Refresh the database, and here it is. The employee table has been created successfully. We also have the columns of the table. Great. Next, let's play around with this entity. By default, the class name is used as the entity name. However, it's considered a good practice to explicitly provide an entity name. I am going to set the entity name explicitly. Let's name it the same as the class name, employee. Then we can also specify the name of the table that we want this employee class to map to. And we can do this using table annotation. If there is no table annotation in a JPA entity class, JPA by default attempt to map the entity to the table with the same name as the entity class. Here, we'll explicitly provide the table name as employee. Now, let's move on the fields of the employee class. The first field is our ID. The value of the ID can either be set manually or generated automatically. In this case, I want it to be generated automatically. If you are familiar with the MySQL, you might know about its auto-increment feature for automatically generating values for the ID field. However, since we are using PostgreSQL, I will use the sequence to auto-generate the ID value. Here, I will specify how the ID is to be auto-generated. For this, we need to use the generated value annotation. Here, provide the strategy. For the strategy, we have a couple of options. First one is auto. This is a default strategy. It allows the persistence provider like Hibernate to choose the most suitable generation strategy based on the database and its capabilities. It adapts to various database environments, making it convenient choice. Then we have this identity. This strategy relies on the database auto-increment feature to generate primary key values. It's suitable for databases like MySQL, PostgreSQL, and SQL Server, which support auto-incrementing columns. The next one is sequence. This is the strategy we are going to use. It employs a dedicated database sequence to generate primary key values. It's a common choice for PostgreSQL and provides control over key generation. Then we have another strategy, table. This strategy maintains a separate database table to manage primary key values. It's less frequently used compared to other strategies but can be helpful in specific scenarios where fine-grained control over key generation is required. We have also UUID. This strategy generates universally unique identifiers using the UUID algorithm. It's particularly useful in distributed systems where globally unique IDs are necessary. For this project, we'll use the sequence strategy as it aligns with PostgreSQL feature. Here, let's run the project. And here is the console. Here, we have this database query is printed in the console. A new sequence has been created. And it also generated a name for the sequence. And here it states that the sequence will start from 1 and increments by 50. This means the ID of the first entry will be 1 and the ID of the second entry will be 51, incrementing by 50. However, instead, I want the ID to increment by 1. This means the ID of the first entry should be 1 and the second entry to 2 and so on. Let's do this. To achieve this, we need to use another annotation, sequence generator. This sequence generator annotation accepts several properties. First one is name. This is a unique name for the sequence generator. This name is used to link the generator to the entity that use it. Here, I will name it employee underscore sequence. Then we have optional sequence name, the name of the database sequence object from which to obtain primary key values. This is the name that will be generated in the database. If not specified, the persistence provider will choose a default. I will name it employee underscore seq, short of sequence. Then the allocation size. This is the number of values to allocate in memory for each tip of the database. I am setting this to 1 because I want to increment ID by 1. Now, let's update the generated value annotation to link it with our custom sequence generator. Provide the name of the sequence generator. It will be the name of this sequence generator, this one. Now, let's start the project and check the console again. No query printed in the console. Here, in the employees class, these sequence declarations looks okay. I think I need to delete the previous sequence that was already generated. Let's check the database. Here is our sequence. I will delete this. For that, let's open the SQL query console. Here, for deleting sequence, the SQL statement is drop sequence, then provide a sequence name. Execute the SQL by clicking this play icon. So our sequence is deleted. Let's verify this in the database. Refresh. Here in the employee table, we no longer have the sequence. Okay, and run the project. Here you can see a new sequence is created with the name employee underscore sequence as we defined, and it increments by 1. Here we can also define the name of the column that this field will map to using the column annotation. Here we can specify the column name. I'll use the same name as this field, ID, and this ID field is auto-generated and should not be updated after it is generated. So set the updatable property to false. Now let's work on the first name field. This field should not be null and the maximum length will be 100 characters. To enforce this constraint, we'll use column annotation. Set the name to first underscore name and make it nullable to false, and set the length to 100. For the last name field, the requirements are similar. To save some time, let's copy the column annotation from the previous field and paste it above the last name field. Now change the column name to last underscore name. For the email field, again paste the copied column annotation. Change the column name to email and set nullable to false. Our email address don't have strict length requirement, so I remove the length property for the field. And for the hire date field, use the column annotation. Set the column name to hire underscore date and make it nullable to false. And for the salary, also use the column annotation. Set the column name to salary and make it nullable false. Now this email of each employee must be unique. To enforce this, we need to add a unique constraint. For that, let's go at the top of the class. Here in this table annotation, add the unique constraints property. We need to use curly braces to specify the constraints. Inside the braces, add unique constraint annotation. Give the unique constraint name. I'll give the name employee underscore email underscore unique, and specify the name of the column that should be unique, and in this case it's email. Now let's start the project. Here in the console, let's check the logs. Here you can see the table has been altered. Here the first name column now has maximum length of 100 characters. Same applies to the last name. A new unique constraint employee underscore email underscore unique has been added for the email column. So we have learned quite a lot about the entity. It's time to talk about the repository and do some database queries. And we'll go through that topic on the next video. See you there. Bye bye.